Have you ever seen this error before? App not responding and suddenly your app just freezes or crashes. Well, it can happen if your service runs heavy tasks on the main thread. And yes, even your background service can be the reason behind it. Hey guys, welcome back to Daily Coding. Last time we created our first started service and it worked perfectly in the background, just like we wanted. But now comes the real deal. What if your service needs to do something heavy, like downloading a large file or processing big data? If you don't handle it right, your app freezes or crashes. Your users get frustrated and you will see that a scary ANR, application not responding. So in this video I'll show you how to fix that, how to run long-running tasks properly inside a service, the clean, safe and Android-friendly way. We'll do it using a simple Java thread. By the end, your service will be powerful, background-friendly and fully under your control. So what we are waiting for? Let's jump right in. Alright, let's quickly understand the problem. Android runs services on the main thread by default. And guess what? That's the same thread responsible for handling your UI, buttons, user input, everything. Imagine your Android app is a busy restaurant kitchen. The main chef is taking orders and cooking small dishes really fast. Now one customer orders a giant dish that takes 5 minutes to prepare. If the main chef handles it himself, all other customers will wait and the kitchen slows down completely. So what is the solution? Well, we hire a helper chef, a background thread who can cook that slow dish, while the main chef continues serving everyone else. This is how exactly threads work in Android. Side helpers that prevent the main app from freezing. However, in our last video, you saw the countdown timer working smoothly. That's because under the hood, it uses a handler and a message queue to schedule the on-tick method. And since each tick runs quickly, it never blocks the main thread, so that UI stays perfectly responsive. If we run a heavy, time-consuming task directly inside onStart command, the app will completely freeze. No button clicks, no scrolls, nothing. And I'm going to prove it to you by showing exactly which thread our service and countdown timer are running on. So here I will add a log message, log E, and print the thread name using thread dot current thread dot get name. Now I will copy this line and paste it inside onTick, also inside onFinish. Perfect. Now let's quickly build and run the app to see the output in Logcat. App has been installed. Let's click on Start Download. See in the Logcat. Service created, service started, then notice the thread name, main. This means our service is running on the main thread. And here's the key point. Anything you do inside a service will run on this main thread, unless you explicitly create a separate thread. Therefore, in our service class, especially inside onStart command, if we call thread.sleep, our app will freeze instantly. Why? Because it will pause our main thread completely. Anyway, now I just want to quickly demonstrate how easily you can run into problems when performing long-running tasks. But before that, let's clean up our service class. I'll take out the countdown timer code, or actually let's just comment it out so we can bring it back later if needed. Alright, now inside onStart command, I will type thread.sleep and here type 5000. That means our main thread will literally pause for 5 seconds. And since thread.sleep can throw an exception, we'll quickly surround it with a try catch. Just press Alt Enter, choose surround with try catch. Perfect. Now I'll put this thread.sleep inside a for loop so the app pauses multiple times, letting you clearly see how running tasks on the main thread causes repeated freezes. Anyway, type for I and hit tab. We will run it 10 times. Inside the loop, I will add a log message with log e and attach the I variable to track each iteration. Finally, I will move our thread.sleep line inside the loop. That's it. Now let's build the app and test it. The moment we start our service, we are expecting the app to freeze. So let's see if that actually happens. Alright, the app is installed. Let's first clear the logcat so it's nice and clean. Now I will start our service. And here in the logs, service created, service started. You can also see we are running our tasks on the main thread. Then the countdown style logs have started printing with a 5 seconds pause each time. And during this pause, try clicking stop download. And there it is, our app has crashed. And the reason because we blocked the main thread for too long. Android detects this as an ANR. Once the system thinks our app is stuck, it kills it to protect the user experience. Let's remove the logcat tag filters so we can see all the error messages. Now scroll a bit to the top, and right here you can see it clearly. This is an ANR crash issue. It happens when our main thread is blocked or takes too long to respond. And this is exactly what we wanted to simulate. We paused the main thread repeatedly, so Android thought our app had hung and killed it. This is why if we don't handle our heavy or long-running tasks inside a separate thread, ANRs will happen sooner or later. I think this demo makes it crystal clear. Long tasks on the main thread are a recipe for a crash. To solve this, we need something that can run our work in the background. We can either create a thread or use an executor service. I have made a simple step-by-step video on executor service, so feel free to check that out later. For now, let's go ahead and create a thread. Here at the top of this YouTube service class, I will create a thread variable so we can access it from anywhere in this class. Type thread. Let's name this variable background thread. Now inside onStart command, we'll initialize our thread inside this if condition. We are doing this so the thread is created only once. You could also create the thread in onCreate, but in this example I'm doing it here inside the if block. Type background thread equal to new thread. And now we need to pass a runnable object inside it, which will contain the actual code we want our thread to run. Think of it like this. Thread is a safe and a runnable is the recipe. The safe is ready, but without the recipe, they can't cook anything. Similarly, in programming, the runnable is where we put heavy operations or tasks that needs to be done. The thread then runs those tasks step by step, just like the safe follows the recipe. Alright, type new runnable, hit tab. Now you will notice a red underline. That's because we need to override the run method. Press Alt Enter, select implement methods and add the run method. That's it. This is the place where we put our heavy tasks, so the main thread stays free and our app remains smooth. Now I will move this for loop inside the run method. This will be our heavy task for now. And here I will make the thread sleep for 2 seconds instead of 5 seconds, just to see the result a bit faster. Let's also print a log message to check what the thread name is while this run method is executing. I'll just copy this log line from earlier and paste here. And then whenever you think there's no more work left for the service to do, you can call the stop self method. For example, here right after this for loop we can call stop self. Simple. Also here in this catch block, instead of throwing an error to the logcat, we can simply call stop self here as well. That way if something interrupts the thread, the service will stop gracefully instead of crashing. Finally, let's start the thread. Type background thread dot start. This will bring our thread to life and start running code we wrote inside the run method. But here's the thing, if our service is closing, like on destroying being called, it's like the restaurant shutting down for the night. You don't want the chef to keep cooking in an empty kitchen. That's just wasting time and ingredients. So in on destroy, we'll stop or interrupt the thread, making sure it doesn't keep running after our app screen is gone. This not only saves resources, it also prevents crashes and memory leaks. Therefore, if the user stops the service, we should also stop our thread gracefully inside on destroy, like this. If background thread not equal to null and background thread dot is alive. If this is so, then call background thread dot interrupts. Perfect. Now if we start and stop our service, it shouldn't block the main thread anymore. Now let's build and run the app to see it in action. Alright, app is installed. First I will close the app and open logcat. Now let's launch our application. And you can see in the logcat that the process has started. Let's tap on start download. Now look at logcat. Service created, service started. After that we get thread name main. That's coming from main thread. And this is the name of our background thread. Now let's wait for the task to finish. Alright, there it is. Service destroyed. That means after the task was completed, our service was destroyed. But here's the thing, if we close our app while the heavy task is running, will it keep going? Let's find out. Now close the app from the background as well. No guys, our task has stopped because the process ended. Although we have completed today's objective, learning how to create a thread, running a long-running task inside it and keep it running as long as the process is alive. But if you want your service to keep running a task even after the user closes the app from the background, then you will need to learn about foreground services. I'll be covering that very soon, hopefully right after the next video. And speaking about the next video, we'll be diving into bound services to understand how components can talk to each other.